All right, so today in this video, I want to address a question that probably none of you are wondering, especially those of you who were in my 8:30 class and saw me demonstrate acceleration by jumping. But can I dunk? Can Professor Bartz dunk a basketball? The answer is no, but it used to be yes. So I used to be able to dunk when I was like 18 or 19. Not very well, not very impressively, but good enough to call it good. So how high does that mean that I jumped? Well, I can reach, I know about, my standing reach is about 8 feet because I can touch an 8-foot ceiling. And in order to dunk a basketball, a basketball rim is 10 feet. So probably about 10.5 feet was the highest point that I could reach on my jump. So that means that height, that's my final position minus my initial position of my hand. So 10.5 feet minus 10.5 feet minus 8 feet is 2.5 feet. But that's American units. We need SI units. So I know just from looking at rulers that there's about 30 centimeters in a foot. So I can convert this. So 0.30 meters, that's good to 2 sig figs, divided by 1 foot is going to give me 0.75 meters was how high I used to jump. And nowadays, I can't dunk anymore, but if I'm playing basketball and there's a wedgie where the ball gets wedged between the rim and the backboard, I'm still the one that needs to go up and get it. So that means I can still reach about up to 10 feet. So this is old me. And so now I can do 10 feet minus 2 feet. Oops, minus 8 feet is equal to 2 feet times same conversion to get that into meters gives me 0.65 meters. And that's the 31-year-old me. So now. Okay, so I might look at that and think about, what does that mean for, or why can't I jump as high as I used to? And there's lots of reasons for that, but what it all boils down to is that I don't leave the ground as fast as I used to, right? My initial velocity upward is what is going to determine how high I jump. So how can I use this information to get an initial velocity? And so this, at this point, probably reminds you of a homework problem that you may be rewriting because it was one of the more interesting problems from the last homework set. If all we know is the height that is reached, okay, so we got 2 different heights, but we can generalize this, right? So if I plot, I called it x, even though it's in the vertical direction, that's fine. X as a function of time, we know that we get this sort of, not sort of, definitely parabolic motion, right? So here is my maximum height that I get off of the ground. And that's essentially all we know. We know that we're on Earth, so we know that the acceleration is equal to g, which is 9.8 meters per second squared. And since I'm defining up to be vertical, it should be negative g, negative 9.8 meters per second squared. Okay, but we know some other facts about some interesting points on this graph that will help us. So the interesting points are ones where we know extra stuff for free. So I know for free, at the top of my jump, that my velocity is equal to 0, right? It's v equals 0 at that point. I also know that this is symmetric, so the absolute value, of my initial v0 is going to be equal to the absolute value of my final velocity, right? So, and that's true for any points in between, right? So here I have positive initial velocity, when I land, my landing speed is the same as how I took off. It's just going to be a negative sign. Okay, so how can I make use of this special point here, this point where the velocity is equal to 0, to get some information? Well, the way that I do that is I can break down this motion, right? I call this V0, but it doesn't have to be, right? I could say, let's just cut this motion in half and look at the second half of my flight. So, calling it flight might be a little bit generous. But basically, I reach a highest point and then I fall from there, right? So that's just a free fall problem where it's the same as being released from rest, right? So if I, if I jumped in the air and somebody sitting next to me, held a rock, and right as I got to the top, next to my feet, they let it go, the rock and I would follow the same path and land at the same time, right? So it's just free fall motion from the top of the jump. So from there, I can say, okay, how long does it take to fall? 75 centimeters, 0.75 meters. And then, how fast do you get going if you free fall for that amount of time? That'll give me this velocity, which then gives me that velocity. Okay, so that's our plan. So, second half, free fall. So, as always, I have just two kinematic equations. I know position as a function of time, and I know velocity as a function of time. So position as a function of time, x, which is going to be equal to the height. So I'm calling, let me be a little bit clear about this. Might need to cut that part out. So in this case, I'm starting from some positive position. So that's my height. And I have some initial velocity. And then I have some acceleration. Well, now this is going to simplify a lot because what's my final position? 0. What's my initial velocity? Well, at the top of my motion, I can see that my velocity is 0. So this term goes to 0. So now I can solve this for time pretty easily. So I get negative h, so I'm just going to move that h to that side, is equal to 1/2 at squared. So I'll multiply by 2, divide by a. I get negative h over 2a is equal to t squared. That might look problematic because I'm going to take the square root of a negative number, but that's okay because my acceleration is going to be negative. So when I do that, I get t is equal to square root of negative h over 2a. Okay, so at this point, it would be all right to put a number on this if you feel like it, but you don't have to. You can keep it as is, and then just get numbers at the end. So I want to be able to use this to find out what my velocity is. So maybe I'll just erase the graph here. So here we're still looking at the second half motion, and we're looking at the velocity. So velocity is equal to v0 plus at. Well, again, we're starting from the top of the motion, so v0 is equal to 0, and the velocity is equal to at. Right, so I can plug in what I have from there. So I get velocity is equal to a times this whole square root thing, so I've got negative h over 2a. Right, and this is going to give me a negative number at the end because what I'm really calculating is my landing speed. Okay, so now if I want to simplify this so I don't have to plug as many numbers into my calculator, I can bring the a inside of the square root. So I'm going to get negative h a, so that would give me an a squared, so it cancels out down here. So I've got velocity is height times the acceleration over 2, all inside a square root. And this minus sign is going to kill that minus sign eventually. So if I want to be, if I want to get rid of that distracting minus sign, I know that a is negative g, so I can just write this as hg over 2 square root. Okay, so before we plug numbers in, should make sure that the units work out on this. So I think in class I've been using green every time I check my units, so kind of stay consistent here. So I've got position is meters, acceleration is meters per second squared. So I've got meters squared per second squared, but that's under a square root. So when I take the square root of meters squared per second squared, that kills one of each of the meters in the seconds, so I get the units are meters per second, which is what I should have for velocity. So if I make myself some space, I can calculate how much my velocity is decreased. All right, so here I can calculate my velocity for these two different heights, what I used to be able to do and what I can do now. Just realized I made an algebraic error there. That shouldn't be 0.65, that should be 0.60. That's an arithmetic error. Okay. Right. So we can see here the benefit of not calculating the time as a number in between, because if I calculated the time as a number before, I'd have to calculate it once so I'd have to calculate a time for this height, and then plug that into my velocity calculation for this height, and then I'd have to calculate a time for this height and plug it in my velocity calculation for that height. So now I can just do 2 calculations instead of 4, and my life is easier. So so my velocity as a teenager is going to be equal to, so now I can plug in numbers. So get out the handy iPhone calculator. So I get, it's going to be square root of 0.75 meters times 9.8 meters per second squared divided by 2. So 0.75 times 9.8 divided 2, and then square root gives me 1.92 meters per second, and then the old guy is going to be the same calculation, just with 0.60 meters, 9.8 meters per second squared divided by 2. So we get 0.6 times 0.6 times 9.8 divided by 2, and take the square root of that, and we get 1.71 meters per second. So we can see that I've lost about 0.2 meters per second off of how fast I'm going when I leave the ground, since I